This lesson is inspired by time spent in Dr. Carroll's lab this summer, and I had the opportunity to work with a clover detector, which is a device that is used to detect gamma rays that are being emitted from a source. The idea of something so small traveling into a detector without being perceived by the normal human eye was one thing I thought students would be interested in learning more about. The 5E lesson plan starts with the idea that measurement is a lot more complicated than maybe we give it credit for. So that starts with an engage that has students thinking about how do we measure things in an estimated form, like walking across the street or pouring milk into a cereal bowl, compared to things that we measure with more accuracy. The Explore challenges the students to do some measurements, and as they do that, they also record information about uncertainty in those measurements they are taking. Because the idea throughout this lesson is that scientists can know things with pretty great degrees of certainty, but there's still always a little bit of uncertainty in measurements. The next phase is the explain, and that will be demonstrated in the video on the next slide.
The first part of this video shows the setup for the black box experiment. This would be the setup that the teacher would create for the students, and it would be sealed with tape. When it's sealed with tape, the students would manipulate the box to try and figure out what is the shape of the maze inside of the container. Either with paper and pencil or with a duplicate set of materials, the student would build the model of what they believe the maze looked like inside. Teacher can either allow students to look inside of the box and see if their model was correct, or compare their model to a hand-drawn example of what it looks like inside the box. Another activity in the lesson has materials for students to investigate Rutherford's experiment and model it using materials that can be found in a classroom. Here are some examples of some materials that could be provided to students: foams with different heights, materials that could be used to build legs, items that could be rolled, and a piece of cardboard or cardstock that could be used to hide the object that they are testing on. Here's an example of what one model could look like from the bottom. Here's the view from the top. In order to experiment, students would roll a marble underneath of the platform and monitor the pattern of the movement of the ball. They'd place a piece of paper on the top and use a pencil to try to track the movement as the marble moves through the system. For example, if I roll the ball and it hits an object and bounces back, I would put a mark that it bounced back at about that point. If I roll it again, it goes all the way through, I would try to mark the path that the ball rolled, showing that in that place it rolled all the way through. Eventually, as the students continue to track the ball's movement, they'll be able to hopefully identify the shape of the object that is underneath of the platform based on the behavior of the marble. The idea is that they will go through the process of experimenting with how this process works, and then eventually they would set up a system for another team to test, and then the other team, not knowing what's underneath, would go through the process of trying to figure out what is the shape of another team's project. The first part of this video shows the setup for the black.
The final step the students will experience is the evaluate process. And in the evaluate, students will curate a poster project that will capture all of the different elements that they've learned about throughout this unit. So they will capture images of the designs that they created themselves, information about scientists who went more in depth and learned more about the structure and setup of an atom based on experiments very much like what they experienced, as well as short essays about what they have learned through the process.